In this video, we're going to talk about some synthesis strategies from Chapter 9, and in particular, we're going to focus on converting between alkenes, alkynes, and alkanes. Okay, in this chapter already, we've looked at ways of converting alkynes and making them more substituted. So if we just react them with hydrogen in the presence of a metal catalyst, we can go all the way from the alkyne to the alkane. And then if I use poison catalysts or dissolving metal reduction, I can go from the alkyne to the alkene. And then, we learned both this chapter and the previous chapter, I can then react the alkene with hydrogen and a metal catalyst to go to the alkane. But can we go in the other direction? Well, we've talked about this a little bit. So we saw in one of the first videos in this chapter how we could prepare an alkyne from an alkyl dihalide. And we did that by reacting it with a strong enough base. And then if we were going to make a terminal alkyne, then we had to add water to protonate it. So if we start with an alkene, I can do a halogenation reaction, where in this case I'm adding bromines to my alkene. And then I can react it with a strong base and water to turn it into an alkyne. So now we filled in a lot of this puzzle. So we know how to go in this direction, and we know part of the way how to go in this direction, and in Chapter 10, we'll sort of fill in this last blank. So let's finish up this video. And so to finish up this video, let's look at a couple different examples. And so I want to propose a synthesis to accomplish the following transformation. And so essentially what I've done here is I started with 1, 2, 3, 4 carbons. I now have 1, 2, 3, 4, 5, 6 carbons. So I've effectively added an ethyl group here. And so I've added a carbon-carbon bond. The only way that we've learned in this chapter to add carbon-carbon bonds is with alkylation of a terminal alkyne. So I don't know how to do alkylation with an alkene, but I know how to turn this into an alkyne. And then once I do that, I can use the terminal alkylation to add on these two carbons, and then I know how to go from an alkyne to an alkene, and I can do that with hydrogen and a poison catalyst. So the first thing I want to do is halogenate this. So if we react it with Br2 and a solvent we often use for halogenation is carbon tetrachloride. And so that's going to give me an alkyl dihalide. I can then turn that into an alkyne by using a sufficiently strong base, and we usually use sodium amide. And then I'll react that with water, and that's going to give me this compound. So then if I react that with the strong base again, which will deprotonate the hydrogen from here, and it'll turn it into the negative ion, which is a good nucleophile, I need to add an ethyl group. And so if I react that with 1 iodoethane, that's going to attach the ethyl group onto here. So that's going to give me this compound. And then my last step to go to the alkene again. And so I want to add the hydrogens here and here. So I want to do a cis addition. And so I can do that. And I don't want to go all the way to the alkane. So I need to use a poison catalyst. So if I use H2 and Lindlar's catalyst, I can accomplish the job. Okay, here's another example. Now I'm starting with 1, 2, 3, 4 carbons. I'm ending with 1, 2, 3, 4 carbons. So I'm not adding any carbon-carbon bonds, but I am going from an alkyne to an alkane, and I'm also adding an OH. So I need to kind of decide in which order I want to do these things. Now, we didn't see any reactions where I can add an OH to an alkyne. When we do a hydration on an alkyne, it's going to tautomerize and convert to a ketone or an aldehyde. So I think the first thing I want to do is convert this to an alkene, and then when I have an alkene, I can use hydroboration oxidation to do the anti-Markovnikov addition to add the OH. So my first step is I want to just reduce it to an alkene. So one way to do that would be to use H2 and a poison catalyst. And so that's going to give me, convert that to a double bond, and then 1, 2, 3. And now once I have this, I want to add an OH, but I want to do anti-Markovnikov addition. So if I do BH3, THF, and then for the oxidation, hydrogen peroxide and sodium hydroxide, I'll do the anti-Markovnikov addition of an OH and an H, and that will give me the desired product. Okay, so in this example, I'm starting with acetylene, and I want to make this compound. And so this has 4 carbons in the chain. This only has 2, so I'm going to need to do 2 alkylation steps to add a methyl group to each side. Then I think if I convert it into an alkene, I can then use syn dihydroxylation to add my 2 OH groups. So first, let's add a methyl group. So if we use NaNH2 to deprotonate my alkene, turn it into a good nucleophile, and then if I react that with iodomethane, that'll add a methyl group to one side. If I do that again, I can add a methyl group to the other side. And I think there are a couple ways I can go from here. This looks like it probably started with the trans alkene, although I think there's a way we could do it with the cis. So if I want to convert the alkyne into the trans alkene, I'm going to want to use dissolved metal reduction. And so for that, we use sodium dissolved in ammonia. So that's going to give me the trans alkene. And now I want to add the 2 OHs to the same side. Right, they're both wedges, so I need to do syn addition. And so there are a couple ways to do that. One would be to react with this osmium oxide compound, and then a co-catalyst, and that should finish the job.